Hello, my name is Santiago Sánchez Domínguez, and today I'm going to present my video for the first topic that I'm going to be talking about is about Kepler and other things that he made. So the first thing that we have to know is who was Johannes Kepler. And Johannes Kepler was a German mathematician, astronomer, and physicist who is best known for his three laws of planetary motion. Kepler worked as an assistant of the Danish astronomer Tycho Brahe, and after Brahe's death, Kepler uses his observation to develop his own theory of planetary motion. His laws laid the foundation for Newton's later law of universal gravitation and were fundamental to the development of modern astronomy. In addition, Kepler also made important contributions to optics and geometry, and his work influenced the natural philosophy of the time. The next three points that I'm going to be talking about are going to be the three laws that Kepler invented. So, Kepler's first law states that the planets orbit the Sun in elliptical orbits, with the Sun at one focus of the ellipse. In the words, the planets do not move in perfect circles around the Sun, but rather in oval orbits where the Sun is located at one of the center points. This law was published in 1609 in his work Astronomia Nova. And so, Kepler's first law is important because it contradicts Aristotle's idea of celestial motions must be circular and uniform, and it paves the way the development of Newton's theory of universal gravitation. The next point, obviously, is Kepler's second law, and also known as the law of areas, states that the line joining at the planet to the sun sweep out equal areas in equal times. In other words, planets moves faster when it is closer to the sun and slower when it is farther from the sun. But it always sweeps out equal areas in equal times. This law was published in 1609 in his work Astronomia Nova as the last law. And Kepler's second law is important because it describes how the planets move in their orbits and helps explain why the planets do not deviate from their orbit as they move around the sun. And the next point is going to be the Kepler's third law, and it states that the square of planets orbital period, also it is the time that it takes to go around the sun, is proportional to the curve of the average distance between the planet and the sun. In other words, the farther a planet is from the sun, the longer it takes to orbit it. This law was published Kepler 1619 in his work Epidome Astronomy Copernicanae. Kepler law Kepler's third law is important because it allows astronomers to calculate the average distance between the planets in the sun from the time that it takes them to orbit the sun. Furthermore, this law also applies to moons and satellites orbiting other celestial bodies. Next point that I'm going to talk about is what is the heliocentric system. So the heliocentric system is an astronomical model in which the Sun is the center of the solar system and the planets, including the Earth orbit around it. This mode one was proposed by the Polish astronomer Nicolaus Copernicus in the 6th century and was later supported by the work of Johannes Kepler and Galileo Galilei. So this model replaced Ptolemy's geocentric system, which had been accepted for many centuries, and became the basis of modern astronomy. The heliocentric system is important because it allowed a better understanding of the movement of the planets and laid the foundation of Kepler's laws, Newton's theory of universal gravitation. Next point that I'm going to be explaining is what is the geocentric system. So the geocentric system is an astronomical model in which the Earth is at the center of the universe and all celestial bodies. So including the sun, the moon, planets, and stars orbit around it. This model was accepted for many centuries in antiquity in the Middle Ages, and was proposed by the Greek astronomer Claudius Ptolemy in the 2nd century. The geocentric system is important because it was the basis of cosmology and astronomy for many centuries and had a great influence on the philosophy and religion of the time. However, in the 16th century, the Polish astronomer Nicolaus Copernicus proposed an alternative heliocentric model that was later confirmed by Kepler's laws and Newton's theory of universal gravitation. So the next thing that I'm going to be explaining is here we can see an image from an ellipse. That it was a topic that we saw in the class, and we know how to make it. And here's the parts that it conforms it. And At the top is the covertice. In there is a line that in this part is the eje menor, and in the other part down left is the eje mayor. So fast in the middle is there are the focus, and at the sides, at the right and left side, there are the vertices, and these are all the parts. So the next topic that I'm going to be explaining is temperature. So, and the first thing that we have to know is what is temperature. And temperature is a measure of the average kinetic energy of the molecules of a substance or an object. The hotter a substance or object is, the higher its temperature, since the molecules move faster and have more kinetic energy. Temperature is measured in different units, the most common being degrees Celsius in the metric system and degrees Fahrenheit in the imperial system. Temperature is an important property of physics and is used in many applications from climate regulation to industrial process control and medicine. The next thing that we have to know is how is temperature measured, and it can be measured in different with different things. But the most common ones are the mercury thermometers that measure temperature by expanding mercury in a sealed glass tube. The digital thermometers measure temperature using a sensor that converts thermal energy into an electrical signal and displays the result on screen. Thermocouples measure temperature by detecting the infrared radiation emitted by an object. The thermisors measure temperature using an electrical resistance sensor that varies with temperature, and the bimetal thermometers that measure temperature by differential expansion of two dissimilar metals bonded together. The next thing that I'm going to be talking about are about the thermometric scales. And thermometric scales are temperature measurement systems that establish a reference point and assign numerical values to represent temperature on a scale. And three most common thermometer scales are the Celsius scale that we also spoke a time before, and this scale establishes as a reference point the freezing point and the boiling point of water, which are defined as 0 Celsius degrees and 100 Celsius degrees respectively. Fahrenheit scale. This scale is also based on the freezing point and boiling of water, but it stays it at 32 Fahrenheit degrees and 212 Fahrenheit degrees and respectively. And Kelvin scale. This scale is based on the point of absolute zero, which is defined as the temperature at which all molecules stop, and is assigned to the value of zero, null Kelvin. In this scale, the freezing point of water is 273.15 Kelvin, and the boiling point of water is 373.15 Kelvin. Now, in this table, we can see how to compare between different temperatures. And as we can see, if we want to convert from Kelvin to Celsius, we, we, we see there that it is Celsius is equal as the Kelvin that you have in the exercise. So it can be 1, 2, 3, 4, 5, and more. And you have to be minus 273.15, and so we different. So we can see here in Kelvin to Fahrenheit is Fahrenheit is equal as 9 multiplying the Kelvin degrees that you have minus 273.15 and dividiendo 5 plus 32. Here I am going to be presenting some problems that we made at class and I made it here at home. So it was homework and I did it. And in the first problem I must complete a table in which I had to convert from different types of temperatures. So it was a table about countries. As you can see, the first one is Mexico, but it was about cities. Sorry. So here is the Distrito Federal, Paris, Londres, Los Angeles, El Cairo, Toronto, Madrid, Toledo, Jerusalem, and Atenas. And here I have the this thing, the thermometric scales. So the first one on the table is Celsius, then it is Fahrenheit, and then is Kelvin. So we can see here that in the Distrito Federal we had 25 Celsius degrees, and I had to convert it into Fahrenheit degrees and Kelvin degrees. So, and yes, it was all that I had to do. And in the second problem that is here, uh, I was also able to complete it using the table with the formulas that I spoke it about a time before. The table with the mathematic things that we have to do when it was Celsius, that it was equal and multiplying and so like that. And in the last problem, I had to convert to degrees Celsius, and I had to say if the water was frozen. And in the end, I was able to say yes because in class uh, we saw that water freezes at 0 degrees Celsius. So, and for close this presentation about my evaluation, I'm going to explain about why are important the topics that I explained. So in the first one is Kepler's law are important because they provided a solid foundation for understanding the motion of the planets in the solar system and laid the foundation for the scientific revolution in astronomy and physics. Kepler laws allowed astronomers to understand how the planets move in space and how they are related to each other, opening the door to new theories and discoveries in the field of astronomy. In addition, Kepler laws were an important step in the transition from the geocentric system to the heliocentric system, which is currently accepted model to explain the movement of celestial bodies in this universe. And the other topic that it was the temperature. I'm going to be talking about the thermometric scales because it was the all that I said about temperature, and it is important to know the thermometric scales because the measurements of a temperature is a fundamental aspect in many fields such as industry, medicine, scientific research, and climatology, among other things. Each thermometric scale has its own unit of measurement and it is used in different contexts. So it is essential to know how to convert between them in order to correctly interpret the data and make accurate measurements. Also, knowing the thermometric scales helps understand how different temperatures are related to each other and how they affect physical and chemical processes. In summary, knowing the thermometric scales is essential for work in many areas and for a fuller understanding of nature and the universe.